So now what we need is the slope. So I have a rise of 1, 2, 3, 4.5, and a run of 1, 2, 3, 4. So a rise of 4.5 and a run of 4, and a plus and minus in front of that. So that's the equation of the asymptotes. There are two lines here in case someone wants to write the positive one here and the negative one there, but I'll accept plus or minus and be okay with that too. Now, I'm either going to be doing the curves this way or this way, but this one, that looks like we have to do it this way because this is the ones where these are the vertex points, vertex and vertex. So that's approximately what the hyperbola should look like. Okay. Oops, I made a mistake. Good thing I caught it before anyone else did here. Here I went to the vertex and went that way, and I didn't pay attention to the fact that that was the focus point there. So it's from here that I need to have the arm coming out, and from here that I need to have it coming out. So be careful with that. I just demonstrated one of the things that could be a common mistake is that people use the wrong point after they put a focus point on there. So just be careful. I even put a V too. Maybe that's why I realized it afterwards that it didn't go through the V. And so it did help me that way. So let's take a look again at what we did. Started out in this case with the equation in general form, completed the square twice in order to get the standard form. We could then use the standard form to do this, where you can find the center, find the coordinates of the vertices, find the direction of transverse axis, the coordinate of the foci, the transverse and conjugate axes lengths, pretty easy to figure out with just doubling them, and the rise over run in the center for the equations of the asymptotes. And then after that, you're just graphing, just be careful of graphing the actual curves. All right, this then would be numeral 2b, and it's the second one. So now you can see two good examples of this, including changing to standard form. On the test, you're going to be changing to the standard form, and you're going to be graphing. In the graphing one, I will not make you change it. There'll be different equations. I'll give you the standard form for that, but you'll have to get the standard form for a different thing. All right, now what we also need to look, the last part of this section, which we'll call part 3, is to make the equation given certain information. Make the hyperbola standard form equation given certain information. So let's start with my giving you, call this one A here. I'm going to give you vertices, -7, 0, and 7, 0. And I'm going to tell you that the conjugate axis is 10 units. With just that information, we can make an equation. Well, let's review about the equation. Okay, what we need, let me set this up, squared equals 1. What we need is either x or y. We need to figure out which way it's going, which one's positive, which one's negative. We need the h and the k for the center, because the h will go here or here, and the k will go here or here. And we need the amount of A, and we need the amount of B, so we can square them for that. So I can figure out some things here. The center is going to be the midpoint for the vertices. So remember the midpoint formula, and so if I do -7 plus 7, add the two x's and divide by 2, add the two y's and divide by 2, oh, well, I can see now I'm going to get 0 over 2, so I get 0, and I get 0 over 2, so I get 0. So the center is at 0, 0. So that means up here I'll have just y squared or x squared, because y minus 0 or x minus 0, we don't have to show the 0 there. Okay? So now we know the center. We also know the length of the length of A because from -7 to 0 and from 7 to 0 is a length of 7. Okay? And the conjugate axis is 10 units, so half of that would be from the center to an endpoint, so it would be 5 for the B. Now, I will tell you I really like to graph these. So what I want to do here is I want to do a little graph. I don't have to when the numbers are so easy, but it won't hurt either. If I go out to where -7, 0 is, go out to where 7, 0 is, I can see that the center is right at 0. So that tells me that A is equal to 7. And then I can go further. I really don't need to do more than that now because I see this and this. So I can do, what I also see is that shows me, forces me to see that the transverse axis is parallel to the x-axis. It's actually on the x-axis, but it's parallel to the x-axis. That means this one has to be x for this. So I'm going to do x minus 0 squared minus y minus 0 squared, and it's equal to 1. And underneath the x is going to be the A amount, 7 squared, and then the B amount, which is half of the conjugate axis, 5 squared. Now I'm going to clean it up. I don't need the zeros there, so it's x squared. Don't leave it as 7 squared if you're doing something like this. You actually have to do the square. So y squared over 25 and 1. And we have just made the equation. We have the center in it, 0, 0. We have the A, 7, which is squared here, and the B, 5 squared. And now, this is when you have the vertices, and you can get the B from this, you can get the center from that, and the vertices from that. Let's do another one. Okay. Find a piece of paper for what I'll call B. So, 3B. Let's look at, let me give you the vertices. Usually you do get the least of vertices because you get so much information from that. It's hard to get to figure out things if you don't have that. You can, but it's harder to. So the vertices are -2, 1, 6, and 1. And I'm going to give you this time the focus points. The foci are -4, 1, and 8, 1. All right, let's see what we can do with this. First, I can find the center from -2 plus 6 over 2 and 1 plus 1 over 2. So that means 6 minus 2 is 4, 4 over 2 is 2, 1 plus 1 is 2, 2 over 2 is 1. So it looks like the center here is 2 and 1. All right, so that's my H and that's my K. Now, which axis? Okay, well, it looks like I'm on 1 for all of these, but I just don't visualize that very easily. So I'm going to do a little graph of it. So I'm at -2 and +1, and I'm at 6 and +1. This then is the transverse axis. Aha! That means we're going horizontal. So when I set up my equation here, I'm going to have x, it's going to be the x first minus for the y, because we're going that way. The focus points are at -4 and 1. Oh, I went to -1 here. I don't know why I did that. -2 and +1, 6 and +1. Doesn't hurt me right now anyway, because all I'm doing is just figuring out it's parallel to the x squared, and 8, 1. So we'll use that in a moment. We'll use that pretty quickly. So I need the A here, I need the B here. Let's first put x minus 2 and y minus 1 for the H and the K. Equals 1. Don't forget to put equal 1 when you do these equations. Sometimes people forget that and it's not an equation. You're going to lose a point or more if you're not remembering that. All right, back to here now. So what I need then is if this is 2, 1, 2 and 1, what's the difference here from 2 to -2? Looks like that's a distance of 4. And from 2 out to 6 is a distance of 4. Okay, now that means that using that, finding really literally the distance from 6 to -2 is 8, and half of that is 4, so that A is 4. Okay. Well, In order to get, oh, that means coming down here, that's 16, that's a squared. So if a is 4, we're at 16. I got the a from 6 to -2. Well, if I go from 6 down here, that's distance is 6, and then 2 more gives me a distance of 8. Or if I use the center, from 6 to the center is 4, and from the center out to -2 is 4, and so either way I can see that a is equal to 4. Well, now I need c. C squared equals a squared plus b squared. C squared equals 16 plus b squared. I don't know b squared. I do know c squared because I know here if I'm at -4 or if I'm at 8, the center's at 2. Going from 2 to 8 is a distance of 6. Going from 2 to -4 is a distance of 6. That means c squared is 36. Square root 6. Subtract 16, b squared is equal to 20. So that means that b is approximately, if b is equal to the square root of 20, already figured that out before, and I read the number, it's about 4.5. Okay, let's verify it. There I have it from an earlier one. Square root of 20 is about 4.5. So approximately 4.5. But I wouldn't use that here. Oh, wait a minute, I went too far, I didn't need it. All I needed was that. It doesn't hurt that I went too far, it's just that all I needed was the 20. All I needed was b squared. Done. So I could use c and c squared to help get me b squared, and I didn't even have to go to 4.5 as an approximation because I'm not graphing it. All I'm told to do is to make the equation. And I made the equation using the vertices and information I could get from that, and using the foci to help me get the b squared. Okay, let's do one more of these with a different thing, because on this one you're using vertices and foci to make the equation. On this one you're using vertices and the amount of the conjugate axis to make the equation. Okay, now let's do a final one. 1, 2, 3, C. Okay, so on this one, we're going to do the vertices again. 1, -8, 1, and 8. Okay, and the equations of the asymptotes, y is equal to plus or minus 2x minus 1. Okay, well, what information do we need? We need the center, so we need the h and k for the center, and we need the a, and we need the b. But we can get the center from the point-slope form. This is supposed to be y minus 0, so it looks like k is 0, and we have 1 for the positive 1 for the h. So the center is a positive 1 and a 0. Okay, so that helps us with writing up the equation. With the vertices here, so I can use the midpoint formula, or I can do a little graph of it. So I'm going to do a little graph of it. Positive 1 and -8, positive 1 and 8. And the center is here. Well, that tells me that the a is equal to 8. Okay, that's cool. Okay, well, now I have to figure out the b, and all I have left is the equation of the asymptote. I can use the slope here, because the slope, you could think of it as b over a, but it's a rise over a run, and it's been reduced. So let me make this equation a little bit larger and show you how to think about this one. 1, 2, not equation, make this graph a little bit larger. Let's do that. So I'm going to go up 8. 1, 2, here's the center. 1, 2, 3, 4, 5, 6, 7, 8. Okay. And I can go down 8 without moving 2, 4, 6, 8 will be about here. Well, the slope is 2 over 1. So if this amount is 8, I then have to go over some amount. And it's not 2 and 1 for that. I'm going up 8. So if the slope is 2 over 1, and that's the rise, and that's the run, rise so you can read it. Well, the rise I'm really looking for is an 8, not a 2. 2 and 1, 2 and 1, 2 and 1, 2 and 1, and then I would be equal with that, so that means that I could get the distance this way. This would be B, this amounts A. But you notice I had to do 2 and 1, and I couldn't stop there because I hadn't gone up all the way to 8 yet. So 2 and 1 again is 4, 2 and 1 again is 6, 2 and 1 again gives me the 8. So I need to know how far over this is. And I could count them that way and see that it's a distance of 4. But I can also see that to make the 2 into an 8 is times 4. Therefore, to make the 1 into something, I'd have to use the same times 4. So 1 times 4 is 4. So that means the rise over the run is really 8 over 4. Okay, and in this case, oh, I did, wait a minute, is that A or is that B? Oh, okay, yep, I am going that way. The A is this way and the B is that way. I had to make sure I remember right now which axis I'm parallel to. So it's y squared. So it's okay to have the A on top here. You have to. So going a rise of 8, and then the appropriate run is 4. So that means the B is equal to 4. Now I have enough information to write the equation. Because we're parallel to the y-axis, that means the y's come first. There's more than it should have here. Okay, and then equals 1. So here it's y minus 0 and it's x minus 1. And the a squared is 64 and the b squared would be 16. And then I can clean it up because I don't need to have a minus 0 there. So it's y squared over 64 minus x minus 1 squared over 16 equals 1. And there is my equation. I was able to get the center from the midpoint. Actually, I got the center from the equations of the asymptotes. There, I just realized you put an E in there. I also could get it from the midpoint of the vertices, or by graphing it and finding the midpoint. I could get the A from the distance for between the vertices, and half of that. I could get the B from using the slope. This is the harder one because it's not immediately the correct rise over run, or it's a reduced rise over run. You have to expand it again by making the rise equal to 8 instead of equal to 2, and that changes the run to a 4, and that's your B, because rise over run is the A and B for hyperbola. Okay, there's our equation. So what you see here, let's just review the things to do with the hyperbolas. You see here that 3 different examples of having to write the equation giving some information. And then also these examples where you're changing to standard form, right, where you have to make the equation. And then in other problems where you're given the standard form and you have to actually graph the graph. So you now have some good examples for that. Make sure you practice them and get comfortable with all the parts of the hyperbola. And hopefully this was helpful to understand what to do and to be able to do it on your own.